Let's go to League 2102. Sequentially ordinal rank tracker. For this question, let us to design a data structure which we can add a scenic location, and let's implement the add and get method. So add will add the scene with name and the scope. You see that these names are unique. And for the get method, it will get the ice-based item. So what is ice? So every time we call get, then we that is the ice code of the get, right? So if the first time we call get, it will get the best location. And the second time we call get, so I'll get a second best. So it lets us to design data structure. Let's look at it have some constraints that say that at most 4 multiplied by 10 to the power 4 calls in total will be made to add and get. So that means if this kind of add and get, there are some kind of log operation, time complexity. And if we have 4 multiplied by 10 to the power 4 and log 4 multiplied by 10 to the power 4 should be in our safe time range. So for the log time complexity, we're thinking about is we can use some kind of priority queue for this question, right? Actually, for this question, we can use 2 priority queues. One is a min heap, and another is a max heap. So the min heap, it will always keep in those kind of items with the beta, let's say score, right? And there is score here. Let's say beta value, okay, with beta value. So this value, how we determine the value? Value is that first we compare the score. The item with higher score will have beta value. And if the scores are the same, right? Then the name with smaller lexical order will have beta value. So we compare score first, then name, right? The score bigger is beta value, and name smaller is beta value, right? So the step for us to handle this kind of add and get is that when we add an item to our min heap, and then we pull this item from our min heap to this kind of max heap. So there are 2 steps. One is add to min heap, and another is pull out. So doing these 2 steps, there are some functionalities. First thing is that we'll say we get the smallest item, right, from min heap to max heap, and all of those kind of in min heap they are beta value, right, higher value. That means we get the worst one to the max heap, and in this case, it do one functionality is to do a balancing, right? Every time we add this kind of item, we always keep in. For example, we have 5 base items in the min heap. Now we are still keeping 5 base items in the min heap. Another functionality is that we keep those kind of min heap size, right? That means our add functionality does not change the min heap size. So this will be the min heap, and what will be this will be the add method. What will be those kind of get method? For get method, what we do is that we are going to get the base value from the max heap and add to the min heap. So this is the first step. And another is we use pick method to get the min heap, the last item, right? So the last item so is the min heap size, right? Use pick to get its name. So this one also do two things. Is one is adding one item to the min heap, so that in this case we'll find the min heap the size will be equal to the get method cost, right? So this will get it the ice based location always been using this kind of get method, right? So we get one item from max heap to min heap, and then we use pick. So in this case, we don't need any variables like get counts, right? We just need use two powered queue to maintain. So let's write code for this, and we need a items class. Let's have a class item, and we have int store and a string name, right? Let's have public constructor item. Of course, you can also call it a scene, int score and string name, right? So let's say this dot score equals score. This dot name equals name, right? So we need two powered queues. One is a min heap, another is a max heap. Priority queue, item, min heap, and the max heap. So for the min heap, will be new priority queue. Let's say A, B, right? So if A dot score equals B dot score, then we're going to have because the lexical order was will be this kind of value to be smaller, right? So we'll say B dot name compared to A dot name, right? Otherwise, we are going to have integer compare A dot score, B dot score. So this is a min heap. And also the max heap will be reversed. We'll have A dot name compared to B dot name and B dot score, B dot score, right? So the process is that we use min heap dot offer a new item score and name, right? And then we're going to have a max heap offer min heap dot pull. So we'll see these two lines code balanced those kind of items, getting always the beta items in the min heap, right? Not because we add another item. And also it doesn't change the min heap size. And for get, we'll have min heap dot offer max heap dot pull and return min heap dot peak dot name. integer compare a dot score compare to for a dot name. Find a symbol score. In the Python code, the things that for Python, um, it is better that we create two items because when we create one item in the min heap and the max heap, right? So we can get the score, for example, use a minus negative score. But for the for the name, we cannot use some kind of negative name or those kind of things. So we can do like this: import heap q and write a min item. For the min item, we define self score, and this one will be int, and the name will be string. And what we do is that self dot score equals score, and self dot name equals name, right? So we define less equal to um, lt and self other. So what we do is that if self dot score equals other dot score, then return self dot name is greater than other dot name, right? Because the lexical greater will have a smaller value. Otherwise, return self dot score is smaller than other dot score. Right. So we can also define a class called a max item. So we can copy this, but in a reversed order. So so we just change these two orders. So we in our main function we create a min heap and max heap. So when we add, right? So what we do is that heap q dot heap push self dot min heap, and now we add a min item. So name and let's get this item out equals get one after we add one to a min heap, right? We are going to pop one item from min heap. That's why heap q heap pop self dot min heap. Then we're going to add a max item heap q as a heap push self dot max heap max item. it dot score, it dot name, right? So for the get method is we're going to have it equals heap q dot heap pop. So we are going to have a max, max heap get one item out. So we are going to have heap q dot heap push. And then now we should push to us min heap and min item it dot score it dot name. And so what we are going to return is self dot min heap use index 0 as a peak name, right? Min item no arguments. So min item score name self min heap what's store name name fix no argument int name min item uh it line 33. So doing like this, for every operation will be a log operation. So if we have, for example, called k times, right? And averagely we have two k over two items in those kind of data structure, right? So it will be an log k operation. And if we call k times, that is k log k time complexity.